what I want to do in this video is to talk a little bit about spectrophotometry. Photometry, which sounds fairly sophisticated, but it's really based on a fairly simple principle. So if I have, let's say we have two solutions that contain some type of solute. So that is solution 1, and then this is solution 2. And let's just assume that our beakers have the same width. Now let's say solution, let me put it right here, number 1 and number 2. Now let's say that solution 1 has less of the solute in it. So let me make, so that's the water line right there. So this guy has less of it. Let's say it's yellow, or to our eyes it looks yellow. So this has less of it. So this has, actually let me do it this way. Let me shade it in like this. So it has less of it. And let's say solution number 2 has more of the solute. So it's more. So I'll just kind of represent that as more closely packed lines. So the concentration of the solute is higher here. So let me write higher concentration. Higher concentration. And let's say, and this is a lower concentration. Now let's think about what will happen if we shine some light through each of these beakers. And let's just assume that we are shining at a wavelength of light that is specific to the that is specifically sensitive to the solute that we have dissolved in here. But I'll just leave that pretty general right now. So let's say I have some light here of some intensity. So let's just call that the incident intensity. I'll just say that it's I0. So it's some intensity. What's going to happen as the light exits the other side of this beaker right here? Well, some of it is going to be absorbed by our little molecules inside the beaker. So you're going to have less light come out the other side. I'll call this I1. Now, in this situation, if we shined the same amount of light into this beaker, so it's the same number, that and that is the same intensity of light, what's going to happen? Well, more is going to be absorbed as the light travels through this beaker. It's just going to bump into more molecules because it's a higher concentration here. So the light that comes out when you have a higher concentration, I'll call that the intensity, I'll call that I2. This is going to have a lower intensity of light that's being transmitted than this one over here. In this case, I2 is going to have a lower intensity, is going to be less than I1. If you have another beaker that is maybe twice as wide, it's twice as wide, and let's say it has the same concentration as number 2. We'll call this one number 3. It has the same concentration as number 2. So I'll try to make it look fairly similar. And you were to shine some light in here. Let's say you shine the same light in here, and you have some light that makes it through, that exits. And this is actually what your eyes would see. So this is I3 right there. What do you think is going to happen? Well, it's the same concentration, but this light has to travel a further distance to that concentration. So once again, it's going to bump into more molecules, and less and more of it will be absorbed. And so less light will be transmitted.